Hey guys, in this lesson we're going to take a look at angle side angle and angle angle side triangle congruence theorems. So to start off with, we're going to start with angle side angle congruence theorem, but part of that theorem uses the words included side. So just as a reminder, if you've forgotten, included side is an angle that is between an included side is a side that is between two angles in a triangle. So if we're looking at this triangle here on the left, if we're looking at an included side, let's say we want to talk about side AC, it would have to be included between angle C and angle A. So that you could say side AC is included between angle A and angle C. And notice that the names of the angles that include that side are the same angles, are the same letters that are in the name of that segment. So that's one way to help you remember that those two need to be in between. Okay. That being said, looking at our angle side angle, and those are the angles we're going to use, angle side angle. If you have two angles and the included side of one triangle, and those are congruent to two corresponding, or ones that match up to two angles in the included side of another triangle, then the triangles are congruent. So let's say they tell us that angle C is congruent to angle F, and angle A is congruent to angle D. So angle C is congruent to angle F, and angle A is congruent to angle D. Now when you're doing angle side angle, the side has to be included. So that means it has to be between the two angles that you're working with. So you have to have your side AC between those two. So AC would have to be congruent to the side that is between the two congruent angles over here as well. So we went from A to C, so we've got to go from D to F. So if you're able to show those three things, that angle C is congruent to angle F, and angle A is congruent to angle D, and side AC is congruent to side DF, then you can say that the two triangles are congruent. So we have one angle followed by one side followed by a second angle. So then we can say that triangle, let's go ABC, is going to be congruent to triangle. Now here we started with the one that has two arcs, so we've got to go triangle D. The one with none comes next, so the one with none goes there. E, and then the one with the angle with one arc comes next in this triangle, so we got to go with the angle that has one mark in that triangle. Okay, so there's our triangle congruency statement for the angle side angle congruence theorem. So if we give that a try, they can give you all kinds of different problems to do with these. They could give you angle measures, side lengths. They could also just use tick marks and those arc marks to show you side and angle measures. Looking at this example, it says, which two triangles are congruent by the angle side angle theorem? Complete the triangle congruence statement. So if we look in this triangle, we have two arcs for one angle, so two arcs, two arcs, two arcs, doing okay with that. Then we have a side with two tick marks, one tick mark. So it can't be this one right here, because in order for them to be able to be congruent, they have to have the same exact angles, two arcs, one arc, and the same number of tick marks on the side. And this is also something that you need to remember for these. You need to make sure that those tick marks for both triangles are between or included between those two angles. There you will get tricky problems on some standardized tests that would have put two tick marks over here, and then everything would have been the same except for RT would not have been included between angle R, and angle S, so keep an eye out for those and make sure you're doing inclusion. So now that we've picked out the two that are congruent, it's just a matter of writing the congruency statement. So let's go XYZ. So triangle XYZ is going to be congruent to X has none, C has none, Y has 2, B has 2 arc marks, and Z has 1, and D has 1. So triangle XYZ is congruent to triangle CBD. Some other things that they could ask you to do is they could ask you to do complete proofs on these. And you just use the information that they give you along with that list of good reasons that we've been working on, and use it to help you fill in the blanks. So looking at the first one, they tell us that RV is congruent to RT. So RV is congruent to RT. RV, RT. And you can use tick marks, but I'm going to use the colors to help see. And there's where it is in the proof. Okay. And that's all they gave us to work with. And then from there, we have to find other things. So it says complete the proof. So looking at the picture, another piece of information they give us using this little arc mark here about angle T and angle V, that tells us that those two are congruent. So that's taken care of there. So then they say angle R is congruent to angle R, which is this arc mark here. Well, that angle is in the same exact spot for both triangles. If you're looking by both triangles, I see one triangle here. And another way to see is, well, they name it straight out. So RTW is one triangle, and RVS is another triangle. So if we look, this angle, R, is the same angle in both of them. And whenever you're looking at same angle is congruent to same angle, or same side is congruent to same side, that's going to be the reflexive property. And you've got to be careful because they can give you two different options for these. They can give you the reflection property of congruence, and they can also give you the reflexive property of equality. And you've got to watch what symbol is between the two names and make sure you pick the one that matches the symbol. So this is going to be the reflexive property of congruence. All right, so looking at what they've given us, we've got angle V to T is one angle. We've got RV to RT is one side, and we've got angle R to angle R is one angle. So then we've got our options of angle side angle that it could be, or angle angle side. So then we need to go and look at the picture and look at the order of the things in the picture to decide which one's which. So we've got angle T here. I'm looking at that yellow triangle first. We've got angle T, and then they talked about side RT, and then angle R. So this one's going angle, side, angle. So that's what this one's going to be. This is going to be the angle, side, angle congruency theorem. So looking at the next one, example says W is the midpoint of SU. Complete the proof that those two triangles are going to be congruent to each other. So we've got W is the midpoint of SU. So if I put that in the picture, that means that's the midpoint there of that whole line right there. W is the midpoint of SU, and the way we know that is because it's been given. Looking in the picture, they also tell us that that angle right there is congruent to that angle right there, which is step 2. Angle U is congruent to angle S. This is also given. I know it's not stated up here above, but it's shown in the picture, so it's also count as a given. Okay. Looking at the next statement they give us, they tell us that SW is congruent to UW. So SW is congruent to UW. Well, that's not given to us in any of the information up there above, so we've got to use something stated in one of these two statements right here to say that those two are equal. Well, this one says W is the midpoint of SU, and midpoint means to take a segment and cut it into two equal parts, and that's what this says right here. It says the two parts are equal and congruent. So using this right here, we're using the fact that midpoint means two equal parts, and that makes this step here be definition of midpoint. Okay. Looking at the next one, they tell us that angle SVW, or sorry, SWV, and I'm going to use two arc marks because there's one there, is going to be congruent to TWU. Okay, and the way that those two angles are going to be congruent, if you look, what types of angles are those? Those are vertical angles, and we know vertical angles are congruent, so this is going to be definition of vertical angles, or vertical angles are congruent. That'll work too. I think what this program uses though is definition of vertical angles. Okay, so looking at the information we have so far, here we have one angle, here we have one side, and here we have a second angle. So our options are going to be angle, side, angle, or angle, angle, side. It can't be side, side, side because they didn't give us three sides information. It can't be side, angle, side because they don't give us two sides to work with. So that's why it's got to be one of those two. So then it's a matter of looking at the picture and seeing what they show us. So here's an angle, here's a side, and there's an angle right there. And the side is included between those two angles. So that makes this congruency work because of angle, side, angle congruency. Alrighty, looking at the last one, you could get one where you have to add on and help it finish out the proof. So you just look at what they give you, what you need, and you see how I've been making these lists. See what you have missing and then fill it in. So looking, we've got ST is parallel to RU. So ST is right here, is parallel to RU. And then we also have that RS is parallel to TU, and those are both in our given right there, and I'm going to use two arrows for this one, that way you can tell the difference. Okay, and then it tells us that angle RTS is congruent to TRU, so RTS is congruent to reading the wrong line, TRU. And those, if you look at this as a transversal, those are alternate interior angles, and they already told us that, so there's that right there. And then they also tell us that angle SRT, I'm going to use two R marks, is going to be congruent to RTU. So if you look at the, and then they don't give us any more. So if you look at the information they've given us one angle here and a second angle here. So we don't have a congruency theorem that does angle, angle, angle. So it's either got to be a angle, side, angle, or an angle, angle, side. So that means either way, we're going to have to put a side into our proof. So looking here, just because they're parallel doesn't mean they're going to be congruent to each other. But if you look, we have the same exact, we have a side that's touching itself right there for the two separate triangles, RTU and TRS. So when you have a side that touches itself, just like in this example right here, we had an angle that was overlapping in the same angle here. It's kind of the same idea here. We have a side that's overlapping itself, and it gives you the side angle, the same side there. So then we can say TR is going to be congruent to TR. So same thing congruent to same thing is going to be our reflexive property of congruence. Okay, and that'll give us our side. So here we've got we've got an angle, side, angle in that triangle, and an angle, side, angle in that triangle. So we are able to say, because of angle, side, angle, we have two congruent triangles, but we've got to make the triangle congruency statement. And anytime I do these, I make sure that I'm using the same exact order that they have up there. You could probably put it in a different order, but that always makes me nervous because usually when they do proofs, they want you to put exactly and prove exactly what they have written above. So whenever you do this, make sure you're putting it in the same exact order that they have here. So triangle RTU is going to be congruent to triangle TRS. I'm just checking that's what we've shown in the picture. RTU, so 2 arc marks to 1 arc mark to none, goes to TRS, 1, 2, none. All right, looks good. So there's your couple of different examples on how to write proofs for your angle side angle congruence and how they could give you a picture and ask you about angle side angle congruence. The other thing we're going to talk about today is angle side angle congruence theorem. And the way this one works is it's kind of the, well, what happens if the side is not included between the two angles? You're going to have the angle side congruence theorem. And it doesn't matter which side it's going to be on because it'll go angle side that way or it'll go angle side that way. So and that's some of why it's so important to be looking for that included side, because that's the only difference between these two different theorems. So looking at this one, if two angles in a non-included, so not between the two angles, side of one triangle are congruent to the corresponding angles in the corresponding non-included side of a second triangle, then the triangles are going to be congruent. So if we draw what that's going to look like, let's say we've got this angle right there is congruent to that angle right there. And then we have this angle right here is congruent to that angle right there. And then for the last one, let's say we have this side right there is congruent to that side right there. Could have been this one, but that's just the one we picked. So we would have to say angle A is congruent to angle D, and then angle B is congruent to angle E, and then side CB is going to be congruent to, I went no arc marks to 2, so we got to go no arc marks F to E. Okay, so there's one angle, there's a second angle, and there's our one side that we need. So if we're able to show those things, this one not being included is the big deal, then we can say that triangle ABC is going to be congruent. So I went ABC, so 1, 2, none. Triangle DEF. Okay, so to give this a try, looking at our angle congruence theorem given pictures, which of the two triangles are congruent by angle side? So if you look, 1 arc mark, 2 arc marks, 1 side mark. So 1 arc mark, 2 arc marks, one with 2 tick marks. So this one, so it's either got 1 or 2 is what it's going to be. This one has 1, so that means it can't be this one. So again, a way they could try and make this tricky is they could put 1 arc mark there, and then it would look like it would be, those would be congruent, but they can't be because the big deal with angle side is non-included. So not in between. Okay, so that means it's going to be those two. So I'm going to go XYZ. Triangle XYZ is going to be congruent to, I went no arc marks to 1, so no arc marks is H, to 1 is G, and the last one is I. So there's our triangle congruency statement. And again, you don't have to put it in this order. You can put the letters in whatever order works best for you. You just have to make sure that X is in the same spot as H, and Y is in the same spot as G, and Z is in the same spot as I. So if we start trying these out proof-wise, looking at the first example of those, it tells us that TV bisects angle UTW and angle U is congruent to angle W. So if we find that in our picture, TV bisects UTW. So TV bisects that angle right there. And I know I'm already putting the arc marks in there, but that's pretty much the only way you have to show that this segment bisects that angle. So we're just going to double check that it's stated in here. So TV bisects UTW. So there's that in our given right there. So we should be keeping in mind that whenever we find these two angles congruent to each other, it's probably going to have something to do with that. And then the other part of our given tells us that angle U is congruent to angle W. So angle U, angle W. And I'm going to go 2 arc marks because that one has 1. Alrighty. So then looking at what they tell us next. Angle UTV is congruent to VTW. There it is. There's what I was looking for. This one right here, that one right there. So this is where it's using what it means to bisect an angle, and that's the definition. And they can say angle, they can be specific and say angle bisector. They can also go general and just say definition of bisector, but they can also go definition of angle bisector and segment bisector. Just make sure you pick the right ones. So here we have an angle and an angle, one angle there, a second angle there, and here we have our first side here. So, but they want us to tell us how they got that side. So for doing that, they say side TV is going to be congruent to side TV. So if we look, that side is congruent to that side right there. So that's another one of those overlapping sides or angles. And whenever you're doing the overlapping ones, those are called the reflexive property. And we got to double check the symbol of congruence. Alrighty. So now they want us to say how those two triangles are congruent. So TVW congruent to TVU, and you just double check it to see what it's doing in the picture. Here's a side, here's an angle, here's an angle. So the side isn't between those two angles, so it's between our angle side and angle side angle we have to pick from. Whenever you have a proof that has two angles, it's going to be angle side because the side is not included between those two angles. So angle side congruency. Looking at the next one where they have us filling in some more blanks. All right, we've got WX is perpendicular to XY. So WX is perpendicular to XY. And the only way I know to show that in a picture is to draw a right angle, because that's what perpendicular means. Perpendicular means it makes a right angle. So WX is perpendicular to XY is right there. And we know that's true because it's given to us. Alrighty, looking at the next one. WX, so we've got WX again, is perpendicular to... Oh, it's parallel to, my bad. I was going to say they can't be perpendicular, not touch. So WX is going to be parallel to YZ. And the way, remember the way we show parallel, we use those little arrows. And there's that statement right there. WX is parallel to YZ. We know that's because it's given. And looking at the last one in our given, WZ. So WZ is perpendicular to YZ. So there's a right angle right there. There's the statement right there. So there's another given. Alrighty. So we got all our given in there, and now we need to prove that those two triangles are congruent to each other. And specifically, they're looking for WYZ and triangle YWX. So pretty much the little left triangle congruent to the little right triangle. So they start us off with angle X, which is right here. So this angle right here is congruent to that angle right there. Well, they're both 90-degree angles, and well, if they're both 90-degree angles, they're going to be equal and congruent to each other, because 90-degree angle right here is going to be congruent to a 90-degree angle right there. And what they do for that one is all right angles are going to be congruent to each other. No matter where they are in a picture, if you've got And it doesn't how many you have. If you've got 2 or more right angles, all of those right angles are going to be congruent to each other. Alrighty, moving on to the next one. So we've got, that'll give us our first angle. Looking at the next one, they give us another angle. They give us XWY. XWY is going to be congruent to WYZ. So let's see, those are angles, and both of those angles touch that parallel line, those parallel lines, at least one of the parallel lines. So if I extend this out and make this be a line to make this be easier to see, here's our transversal right here. And we're just double checking to see, does this angle touch the transversal, the parallel line, and the transversal and the parallel line? They do. And they're inside of those 2 parallel lines, and they alternate about that transversal. So these are alternate interior angles are congruent, and we're using that theorem. Alrighty, so that gives us an angle here, and that we had those 2 already, and that gives us our second angle right there. So then looking at the last one they give us WY is going to be congruent to WY, and WY goes straight through there. And it's another one that overlaps itself. And whenever you have same thing in the same place as the other thing, that's called the reflexive property. And just checking their notation, and it's of congruence. Alrighty, so that'll give us one side. So we're looking at where the things are, because it's either going to be angle, angle, side, or angle, side, angle. So here we have an angle and a side for this right triangle, and then same places, angle, angle, side for the left triangle. So that makes this be angle, angle, side congruency. Alrighty, looking at that, the last example that I've got for you, this is another example where you may need to add in a step or 2. You just got to look at what you have, what you need, and go from there. So we're looking at angle F congruent to angle G, angle F congruent to angle G, and we know that because that's in our given. Looking at the next one, we have EH is going to be perpendicular to FG, so that means 90-degree angles where those 2 meet, and there's that in our given right there. And it wants us to complete the proof. So the first thing it gives us at least a direction to go in. It gives us angle EHF. EHF is going to be congruent to EHG. Well, yep, that's going to be true. All right angles are going to be congruent in a picture. So there's one angle. All right. So here's, that was our second angle, because they give us our first angle there, and then our second angle there. So then, since we've got 2 angles, we're going to either have angle, side, angle, or angle, angle, side. So if we're doing angle, side, angle, they would have to give us some kind of information in there. And in order to be able to do that, they would have to tell us something like H is the midpoint, and they don't tell us anything like that. So next I'm looking at this EH to see if there's anything that could be said about the EH. And if we look, we're going for triangle EGH is similar to EFH. So again, it's a left triangle similar to right triangle kind of a thing. So if we look right here for EH, EH is in the same spot for both triangles. So we can say side EH is going to be congruent to side EH. And we know that because of the reflexive property of congruence. Okay, and that'll give us our first side. So here, angle, angle, side, angle, angle, went the wrong direction, angle, angle, side. So we've got enough to say that those 2 triangles are congruent. So I'm going to use that triangle congruency statement they give us right up there. And triangle EGH is going to be congruent to triangle EFH. And we know that because of angle, angle, side congruency. So there's just several different examples of doing proofs for angle, angle, side congruence, and just given the pictures to work with for the angle, angle, side congruence. And we also had several examples where we worked with the angle, side, angle congruencies and both proofs and the pictures. If you have any questions, be sure to write them down and ask when you get to class.